In the last segment, we were working on stoichiometry, and it's just like what we did before. Starting place, ending place, make some sort of plan, and then do your math. Segment 10 just begins with a new reaction. So what I might ask is, I might ask like I did on the other one, I might ask you the reaction type, in which you would say combustion. I might ask you, is it balanced? And the answer to this one is no. We need a 2 there, which means I might ask you the sum of the stoichiometric coefficients in the balanced equation, which is 5. Then I might ask you a series of other questions, and this is what you would want to expect to see on your test. One equation and a bunch of questions. As far as the stoichiometry goes, what mass of zinc must react completely with 52.35 grams of HCl? Starting place, 52.35 grams of HCl. Ending place, grams of zinc. Again, let yourself think through the plan. You can't go from HCl to zinc without the mole ratio. Grams of HCl to moles of HCl to moles of zinc. That's your mole ratio. Without the mole ratio, you cannot do stoichiometry. Always go through the mole ratio. Grams of zinc. Molar mass, molar mass. So you see, so far for our toolbox, we are not using Avogadro's number. There's no need for it. We're not being asked anything about atoms or molecules. Okay, so you don't use the tool that doesn't apply. It's like saying, I'm going to scoop out ice cream with a sledgehammer. You're using the wrong tool. Okay, now for the sake of the video and keeping it in the time limit, I'm going to give you molar masses, and the molar mass of HCl is 36.5 grams per mole. Molar mass of zinc is very easy from the periodic table, and that is 65.4 grams per mole. Our mole ratio is 2 moles HCl to 1 mole of zinc. Okay, so let's put it all together. 1, 2, 3 conversion factors. 1, 2, 3 conversion factors, and then you retrofit, so to speak. Okay, so we're going to have 36.5 grams HCl, 1 mole HCl, and now we've completed that step. 2 mole HCl, 1 mole of zinc. Now we've completed that step. 1 mole of zinc, 65.4 grams of zinc. Grams of zinc, that's always a good sign. We push some buttons on our calculator. 46.9 grams of zinc. Okay, now as far as questions, I'm reminded that I might also ask you, what would you see on this one? Combustion goes up here. Okay, so this type is single replacement. Sorry, my hand got ahead of my brain. What would you see? Does the reaction go forward? Check your activity series, and you would say yes. So what would you see? You would see a gas. Okay? Page 16. More of the same. Okay, so let's balance. What mass of hydrogen gas can be produced from 65.4 moles of HCl if zinc is in excess? Well, this time we don't have to worry about this. Starting place, 63.54 mole of HCl. Mass of zinc typically means, mass of hydrogen typically means grams. Okay? So our plan is mole of HCl to mole of H2, mole ratio. We don't need molar mass. We're already in moles. And then moles of H2 to grams of H2. Two conversion factors, molar mass, 2 mole HCl, 1 mole H2, 1 mole H2, 2.0 grams of H2, 2 sig figs here, so we're going to need to round. We push some buttons on our calculator, and we should get 64 grams of hydrogen. Okay? Now, last on this segment, I've changed the problem a little bit because I'm starting with atoms. 1.56 times 10 to the 24 atoms of zinc, moles of zinc chloride. Okay, so you have to think plan. Atoms always mean Avogadro's number, which then will give us moles of zinc. Mole ratio, always, 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 zinc chloride, and then stop. You don't need molar mass of zinc chloride because you're already there. Okay? Avogadro's number, 6.02 times 10 to the 23rd atoms of zinc, 1 mole of zinc, 1 mole of zinc, 1 mole of zinc chloride. Okay, so you notice I'm doing things in exactly the same process every time I'm doing it. I'm not doing it anything different. Okay? Push some buttons on your calculator, and you should get 259, or 2.59, excuse me, moles of zinc chloride. Okay, you're in moles, you shouldn't have a giant power of 10. Again, the more you practice this, the better you will get at it. Go back to your book, make sure you do at least 10 problems on each of these. Make sure you can do stoichiometry. Okay, pause the video again if you need to, because moving forward, we're going to talk about what happens when we run out of ingredients, because we know that to be true. And this is where this is new for many of you.